Question 10. The average rainfall in a certain region is approximately normally distributed with mean 41.1 inches and standard deviation of 6.1 inches. Round your answers to the nearest tenth of a percent. What percentage of years will have an annual rainfall less than 44 inches? I'm looking for the probability that X is less than 44 inches. Now we cannot do this unless we convert it to a z-score. Z equals X minus mu divided by sigma. In this case, X is 44 inches. The mean is 41.1 inches and the standard deviation is 6.1 inches. Let's plug those values into the formula. 44 minus 41.1 divided by 6.1. We can enter this into our calculator. Here, I want to make sure I put the parentheses around the 44 minus 41.1. Then divide that expression by 6.1. I want to round this to 2 decimal places because our z table is only accurate up to 2. So let's say this is 0.48. 0.48. And so the probability of X less than 44 is equivalent to the probability of Z less than 0.48. We have converted this to a z-score. Now we can use our z-table. Let's find 0.4 in the row, and the column here is 0.08. Intersect the row and column. We have our solution here is 0.6844. 0.6844. So this is equivalent to 0.6844. Now for part A, we want our answer as a percentage. So let's round that to 68.4%. For part A, 68.4% of the time, we will have less than 44 inches of rain. Part B, what percentage of rainfalls will have an annual rainfall of more than 39 inches? Again, we'll use the formula for part B. We have Z equals X minus mu divided by sigma again, except this time I want to find the probability of X being greater than 39. This is going to be a greater symbol because of the word more. So let's plug in our values. X is 39. The mean is 41.1 and our standard deviation is still 6.1. Let's find the z-score for this number. And so our z-score is negative 0.34. Our z-score is negative 0.34. Now I'm looking for the probability that z is greater than negative 0.34. This is the area to the right. This is the area to the right. So what do we need to do? We need to subtract from 1. So we're going to find the probability of z being greater than negative 0.34. I need to subtract from 1, the area to the left of negative 0.34. The row is negative 0.3. The column is 0.04. Intersect the row of negative 0.3 and the column of 0.04 to get our area to the left, which is 0.3669. But remember, that's not our answer. 0.3669 is the area to the left. We need the area to the right, so we'll have to subtract from 1. 0.3669. This is equivalent to 0.6331 or 63.3%. For part B, we have 63.3%. In part C, what percentage of years will have an annual rainfall of between 38 inches and 42 inches? For part C, I want to find the probability that x is between our values of 38 inches and 42 inches. This means we're going to have to use the z-score formula twice. I will use it with the 38, so z equals 38 minus 41.1 divided by 6.1, and then we'll also use it for 42. 42 minus 41.1 divided by 6.1. This gives us two z-scores. The first z-score is negative 0.51, and the second z-score is equal to 0.15. The second z-score is equal to 0.15. Now we're looking for the probability that z is between negative 0.51 and 0.51. Now this is the area between two z-scores. So to find the area between two z-scores, we need to subtract. We'll look for the area to the left of 0.15 first, and then we'll subtract it from the area to the left of negative 0.51 so we can find the area between. The area for 0.15 is 0.5596. 0.5596. So we'll write down 0.5596, and then we'll subtract it from the area to the left of negative 0.51. The area to the left of negative 0.51 is 0.3050. 0.3050. And so we can subtract these two numbers to get the area between. This is equivalent to 0.2546, or about 25.5%. Now this looks like a difficult problem, but you just have to remember what areas we're looking for. We're looking for the areas between. And for these questions, I can always check my work on the calculator. So let's go to our normal distribution calculator. And we know the mean. The mean is 41.1. Our standard deviation is 6.1. In part A, we are looking for the probability less than 44 inches. So I will search less or below 44 inches, click recalculate, and we get 68.3. Our solution is very similar to 68.3%. Our solution was 68.4%. So there is going to be some difference from the calculator and the actual work if you do it by hand. The calculator is more accurate. I could also do part B. Let's try part B. It says greater than 39. So we're going to change this to above. We'll enter 39. Click recalculate. I got 63.5%. Let's compare that to our answer. Our answer for part B
was 63.3%. So it's very close. So we know we did it right. For part C, I want to be between 38 and 42. Our answer was 25.5%. Let's check on our statistics calculator. Between 38 and 42, we'll click between, let's say 38 and 42, click recalculate. We had 25.3%, which is pretty darn close. We had 25.5%. Again, the statistics calculator is more accurate because we were forced to round our z-scores to 2 decimal places.
Question 12. Complaints about an internet brokerage firm occur at a rate of 1.2 per day. The number of complaints appear to be Poisson distributed. Find the probability that the firm receives more than 4 complaints in a 3-day period. Part A. What is the probability of receiving less than or equal to 4 complaints in a 3-day period? Now, if we were doing this by hand, we would need to find the mean. The mean is equal to lambda times t, and lambda is the average per day. In this case, the average per day would be 1.2, and t is our interval, and that would be a 3-day period. 1.2 times 3 is equal to 3.6. Now the formula for the Poisson distribution is P of x equals mu to the x e to the negative mu divided by x factorial. In part A, we want to find the probability of receiving less than or equal to 4 complaints. So we're looking for P of x is less than or equal to 4, which is P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4. Now that means I would have to use this formula 5 times. And I definitely can, and I will get the correct answer. But we can also use technology. So let's use technology for this question. I need the mean, which is 3.6. And I need to use x is less than or equal to 4. So let's go to our Poisson distribution calculator and try it out. We'll enter 3.6 for lambda, but remember this lambda is actually our mean. This calculator considers a t equal to 1, and that's why this is lambda, but just enter the mean here and it should work out fine. X is 4, and we want to make sure this is the less than or equal symbol. So we have our solution is 0.70644, and this as a percent is 70.6%. Again, if you want to practice doing this by hand, plug it into the formula 5 times with each different x value, and you should get close to this answer. Remember, doing it by hand is going to be slightly different because you're rounding each time. For part B, I want to find the probability of receiving more than 4 complaints in a 3-day time period. So the interval is the same, so that means our mean is still 3.2. But this time we're looking for the probability of x being more than 4. So it's strictly greater than 4. Now to do this, I can do it by hand if I wanted to. The first number greater than 4 would be 5. Remember, this is a discrete distribution. That's why we're using whole numbers. Plus p of 6, plus p of 7, plus p of 8, and it keeps going. But if we were to do this by hand, this is not possible. Instead, we do 1 minus p of 0 plus p of 1 plus p of 2 plus p of 3 plus p of 4. Now, why would I need to subtract from 1? Because it's not possible to add p of 5 all the way up forever. That's not going to happen. but I know the total from P of 0 to the end has to be equal to 1 for 100%. But instead I could subtract from 1 what I don't want. Anything below P of 5 subtracted from 1 is going to give me what I do want from P of 5, P of 6, plus P of 7, plus P of 8. Now again, we don't want to do this by hand because that's going to be a lot of work. But just realize, we already done this in part A. We already did this part. This part is equivalent to P of X is less than or equal to 4. I know what that number is. That number is 0.7644. So this is equal to 1 minus 0.70644. And that gives us 0.29356. And of course, I could round this to 29.4%. So this is what I would do. I would subtract from 1 the previous answer, since this is x is greater than 4. Now I could check my work with the Poisson calculator. Let's go to the Poisson calculator and click greater than 4. But look, they don't have greater than 4. So I'm going to actually enter 5 because that's greater than 4. And I'm going to change this to greater than or equal because that's where it starts, from 5. And we do get about the same answer, 29.4%. Question 13. A particular fruit's weight are normally distributed with a mean of 757 grams and a standard deviation of 23 grams. The heaviest 14% of fruits weigh more than how many grams? Give your answers to the nearest gram. Now let's interpret the question. I want to figure out what x value will give me the heaviest 14%. Now 14% is equivalent to 0.14. Now to find this x value, we'll need a z-score. What is the z-score? That will give us 0.1 to the area to the right. Now the table is always area to the left, so I need to convert this to area to the left. So let's subtract this from 1 minus 0.14, and that gives me 0.86. That is the area to the left. Now I'm going to use my z table to look for the closest one. I want the closest one to 0.86 in area. The closest one to 0.86 in area. So let's go to our z table. The closest number to 0.86 in area is this number here. It looks like 0.8599. That's the closest one in area. And the z-score that's associated with that is 1.08. 1.08 is the z-score we need. So this area corresponds to a z-score of 1.08. But that's not our answer. We're going to use that to find x. How do we find x? We use the formula z equals x minus mu divided by sigma. Now I know z, that's 1.08. I need to find the mean and the standard deviation. The mean is 757 and the standard deviation is 23. And now we can plug in the values. We have 1.08 equals x minus 757 divided by 23. Let's multiply both sides by 23. This cancels out. 23 times 1.08 is 24.84. That's equal to x minus 757. Let's add 757 to both sides. X equals 781.84. So let's round that to 782 grams. So the 14% heaviest fruits weigh 782 grams or more.